It couldn't have gone worse for Scuderia Ferrari in the ninth round of the 2024 Formula One Championship, the Canadian Grand Prix, which was held at the 4.36 1-kilometer Circuit Gilles-Villeneuve in Montreal. A weekend of F1 where expectations were very high for the Italian side, and instead, in the end, the worst came to pass. A serious setback that effectively brings the Maranello team back to earth after the emotional high of Monte Carlo. In 2 weeks, in Spain, we will undoubtedly see different results within a different scenario where the prancing horse will necessarily have to provide answers on many issues. In the meantime, we can analyze the race in Montreal, trying to understand what happened for the other top teams as well. Let's examine the average speeds on the straights during the first stint. Observing the telemetry data, we can clearly quantify what Bryan Bozzi, the Monegasque's race engineer, communicated over the radio during the Canadian Grand Prix. On the 3 main straights, Charles Leclerc was losing between 8 and 10 kilometers per hour, compared to the leading drivers due to the power unit problem. Carlos Sainz, although a bit faster than his Maranello teammate, suffered from a less than ideal track position. For this reason, the Spaniard was forced to brake earlier, sacrificing some average speed on the straight. On Saturday, Charles Leclerc was annoyed by a problem with the sensor that records brake temperature, which reported higher than normal values on the right rear unit, sending a false alarm signal on the steering wheel about possible overheating. The problem occurred both in free practice 3 and in qualifying, so much so that the mechanics then intervened under park firm conditions to replace the sensor. However, the problems recorded on Sunday were much more serious and impactful on the Ferrari drivers' race. In the first part of the Canadian Grand Prix, the engineers recorded an issue related to the power unit, with an increasingly significant performance impact as the laps went by. According to data recorded by the Maranello team, initially, the problem caused a loss of about half a second on the straights, but as the track dried and the race progressed, that value grew to about a second. Clearly, however, aside from the engine issue, the Ferrari lacked performance on both days. Ferrari's hope was that a red flag would allow them to fix the problem in the pits without losing positions. Initially, the engineers tried to resolve the situation with recovery procedures, internally called driver default, which allow the team to act on the sensors and other elements of the power unit. However, this was not enough, and taking advantage of the safety car, Ferrari decided to stop the car to perform a power cycle, which is the procedure in which the car is completely shut down, like a sort of reset. Clearly, however, this procedure takes time to complete because the car must go through the 3 phases P0, P1, and P2, which indicate the activation of the various systems, from the electrical part to the thermal engine. During the safety car period, however, the team and driver began to consider their options. Since the risk of rain had significantly decreased, especially in terms of intensity, Charles Leclerc and the team started to consider switching to slicks, in what was a sort of all-or-nothing move. Considering that he would still drop to the back of the group and that the safety car would allow the gaps to close up at least partially, Ferrari took the opportunity to stop and perform the reset. The choice to switch to slicks, as well as to hard tires to go to the end of the race, was shared between the Maranello team and the driver, but the return of the rain right after the pit stop clearly did not reward the bravery of the decision, pushing Charles Leclerc to return to the pits a few laps later to mount intermediates again. While the tire gamble did not yield the desired results, the reset procedure worked as hypothesized, demonstrating that it was more likely an issue with the power unit management part rather than the engine itself. Among the leading drivers, there were no significant differences in general terms, with Red Bull, McLaren, and Mercedes on a similar level concerning this fundamental aspect. The only noteworthy data concerns the hybrid system management on George Russell's W15. Focusing on the telemetry data, it is clear how, on the straight between turns 7 and 8, the silver and black German car of the Englishman uses the additional power provided by the MGU-H and MGU-K motor generators more than its rivals. The challenging weather conditions in Canada allow for an analysis of the average speed maintained by the drivers in 3 different sections of the Montreal track. The layout of the Quebec circuit dried fairly quickly thanks to the new surface, while the race strategy with a constantly evolving track was hindered by the imminent arrival of a new downpour. Rain that ultimately arrived late and with much less intensity than expected. In this part of the Canadian Grand Prix, the 7-time Formula One world champion and future Ferrari driver, Lewis Hamilton, in his Mercedes W15, managed to carry a higher average speed into the corners in all the analyzed sections compared to the other competitors. The British driver's experience allows for equal performance in both slow and fast sections. The experienced Mercedes driver asked over the radio to pay particular attention to the exit from Turn 2, the only section where he was not excelling. The performance of the two McLaren cars was also good. Lando Norris, in his MCL 38, showed a significantly better pace compared to his teammate. During the first stint, both race engineers of the historic British team reminded their drivers of the need to cool the tires. To do this, they moved off the optimal racing line to use the still wet parts of the track. The target given to Oscar Piastri was to keep the rear tires below 80 degrees to limit issues caused by overheating. Thanks to superior pace in both corners and straights, the winner of the Miami Grand Prix managed to close in on Max Verstappen in the early laps and took the lead without much trouble. The two Ferrari cars, on the other hand, were inevitably slower, getting stuck in a group of cars that didn't have the pace of the leaders at this stage of the race. Starting from the back due to a poor qualifying session further complicated things for the most famous Formula One team in the world. For both Charles Leclerc and Carlos Sainz, the focus was also on cooling the tires as much as possible, although their overheating was generally less severe. In the second part of the race, with dry tires, we can more clearly see the true performance of the various cars. Despite continuing to complain about front-end issues and less than optimal behavior on the curbs of his Red Bull RB20, Max Verstappen was overall the best. The Dutchman achieved the fastest average times in the slower sections by maximizing a well-balanced car with little fuel load. Lando Norris was the driver who came closest to the speeds recorded by the world champion. He highlighted the performance of his McLaren, especially in medium-fast corners, showing much stronger pace than his teammate. The young Englishman gained some time over Max Verstappen in these direction changes, at the cost of higher tire wear. The increased energy exerted on the tires forced him, on instructions from the pit, to manage oversteer on exit to conserve the tires. Finally, we analyzed the data related to top speed and the use of drag reduction system throughout the race. The telemetry data we focus on is the one from the section between turns 12 and 13. Where Daniel Ricciardo was generally the fastest, both with the device open and with the wing closed. Among the top teams, Mercedes recorded the best references thanks to a very efficient drag reduction system. When they opened the DRS, Lewis Hamilton and George Russell gained 22 and 25 kilometers per hour compared to laps where the device was not activated. The two McLarens, on the other hand, proved to be better at the beginning of the DRS zone, leveraging a car more adept in traction and cornering. The retirement of the two Ferrari SF-24 cars does not allow for an analysis of their performance in this aspect and opens up some considerations regarding the weekend for the Italian cars. Going from a double podium with a win in the Monaco Grand Prix to a double retirement in Quebec is certainly painful. For the third consecutive Grand Prix, we do not have a true measure of the efficiency of the Ferrari SF-24.